So far, we've only talked about single inequalities that describe just one relationship. But sometimes we have more than one qualification on a value. For example, suppose that we know that to use a certain car seat safely, a child must weigh at least 7 pounds, but not more than 33 pounds. Right, let's say W is the child's weight. There are two rules here. The child must weigh 7 pounds, at least, right? So that means greater than or equal to, but not more than 33 pounds. And the child must follow both of these rules at the same time. So a child that weighs 2 pounds weighs less than 33 pounds, but he doesn't weigh more than 7. A child that weighs 50 pounds weighs more than 7 pounds, but he doesn't weigh less than 33. To show that we need to obey both rules at the same time, we write the word and. Right? And means what it means in English. It means both at the same time. Now let's suppose we encounter a compound inequality and we want to solve it. Right, so suppose some situation gave us the following compound inequality. 5x plus 8 is less than or equal to 6, and negative 4x plus 5 is less than 7. How would we go about solving something like this? First, we solve each of these two inequalities separately. So I'm going to solve this one first. I'll subtract 8 from both sides, divide both sides by 5. I get x is less than or equal to negative 0.4. Now I solve this inequality. Subtract 5 from both sides, divide both sides by negative 4. And what do I have to do when I divide both sides by negative 4? Right, I need to reverse the inequality. All right, so now that I've solved each inequality separately, I do the second step. We connect the two inequalities with and in this case. So we have x is less than or equal to negative 0.4 and x is greater than 3. And then, well, maybe this is telling us too much, right? Maybe the exact details of these two inequalities don't matter. We should simplify if we can. In this case, let's think about what it looks like if we graph this inequality and graph this inequality. Right, so here's negative 0.4 and here's 3. And I'm going to draw 3 number lines like this. First number line, I'm going to graph x is less than or equal to negative 0.4. That looks like this. On the second number line, I'm going to draw x is greater than 3. That looks like this. And on the third number line, I'm going to mark all of the points that are on this shaded bit and also this shaded bit. I see there aren't any points like this, are there? Right, all the points over here are not also over here. All the points over here are not also over here. There are no numbers that are at the same time less than negative 0.4 and more than positive 3. This inequality simplifies to have no solution. All right, that's kind of weird. Does that always happen with an and inequality? Is there always no solution? Let's take a look at another example. Let's consider the compound inequality 3x plus 2 is less than 10 and negative 8x minus 3 is less than negative 19. So what will we do? We'll subtract 2 on both sides here. We'll divide both sides by 3. Over here we'll add 3 to both sides. We'll divide both sides by negative 8. And what has to happen when we divide both sides by a negative number? Right, the inequality reverses. I want to plot 8/3 on the number line. Mixed numbers are my friends here, so I'll note that 8/3 is 2 and 2/3. So my solution is x is less than 2 and 2/3, and x is greater than 2. What does that look like? 2, of course, is the smaller of the two numbers. So on this first number line, I'm going to graph x is less than 2 and 2/3. 2 and 2/3, and everything less than it, 2 and 2/3 gets a round bracket. On the second number line, I'm going to graph x is greater than 2. Here's 2 and everything to the right of it. 2 also gets a round bracket. And now I'm going to look at where the two overlap. It looks like the points that are on both of these lines are the ones between 2 and 2 and 2/3. Same shape bracket over here, same shape bracket over here. So looking at this, right, one, both of these pieces of information are necessary. So I could give my answer as x is less than 2 and 2/3, and x is greater than 2. Or I could give my answer in interval notation. 2 up to 2 and 2/3. Either of these is correct unless we explicitly ask for the answer in interval notation. In the next video, we'll see all of the different ways that these pictures could possibly work out.